In this section, we'll have a look at some questions that you'll likely encounter in the additional testing math section of the aptitude test. So we've got an addition question here, 2495 plus 1239. You simply won't have time to write these numbers on top of each other and add them together using that traditional algorithm. You'll only have 10 or 15 seconds per question. So we'll need to use some rounding techniques to be able to select the right answer without actually having to do the calculation. So we'll first have a look at, well, what do we know about rounding and adding? Okay, so let's have a look at a few examples here. Okay, so adding these first two numbers together, I get 11,955. And what I notice is that this first number is basically 4,000, the second number is basically 8,000, and this result is basically 12,000. So if I look at the two things I've added together, so 3,974 is a little bit below 4,000. In the same way, 7,981 a little bit below 8,000. So the result should be a little bit below 12,000. So we use these sorts of ideas all the time. Okay, another example. 105 plus 319 gives me 424. Okay, again, this is roughly 100, roughly 300 to give me roughly 400, and we'll see that the original things were above what we rounded to, so that result should be above as well. Gets a little bit more complicated when we have numbers that will round up and round down to the nearest 1,000. Okay, in this example, we'll get 7,962. So what we should be thinking is that this first number is above 4,000, but not by much, and the second number is below 4,000, okay, but a fair bit below. So our result should end up being below 8,000. There would be an alternate way of doing this last one, that from the 3953 in my mind I could add 4,000 to get my 7953. And then add the 9, okay, to get me to 7962. So it's really up to you in the moment how you'd go about doing these problems, okay, but ultimately having a bit of flexibility will help you in that moment. So let's go back to our example problem. So let's see how we go. That's about 2,500. That's about 1,200. So I'm looking for an answer that's something like 3,700. Okay, I'll look at my option, and I remember in my rounding, this first one was pretty much 2,500. This one was a little bit more above 1,200, so I'm looking for an option above 3,700. And remember, in the real exam, you won't be writing any of this down. This is just to help our understanding as we go through these concepts. We can do a similar thing with subtraction problems. In this example problem, I've got 909 minus 432. 989 is approximately 1,000. Okay, and then I'm subtracting about 400. So I should get about 600. So looking at these options, I'm choosing between those two. 989, very close to 1,000. And I'm subtracting a lot more than 400. So I'm going to expect to get a response lower than 600 because I'm taking away more than 400. So I'd settle with option B and then move on to the next question. We can do the same thing in multiplication problems. So for example, if I had 9.1 times 6.1 in 10 to 15 seconds, there's no way I'm going to be able to do that traditional algorithm. So I'll have to do some rounding. So let's just think what we know about multiplication and rounding to start with. So if I have 6 times 9, I know that I'll get 54. Okay, if I had 6.1 instead, I'd get something a little bit more than 54. If I had a little bit less than 6, I would get something less than 54. Okay, so I need to keep that in mind when I'm rounding in this example problem. So 9.1 times 6.1, that's approximately 9 times 6. So I'm expecting 54. I've got options here to choose from. Okay, the two things I'm multiplying are both above 9 and 6, so my result should be above 9 and 6. Okay, so I choose option C, and just quickly move on to the next question. Looking at a multiplication problem, we've got basically 1500, so a bit of a round up, and I'll round this down to 20. So it's a pretty significant round down. So whatever I get, I'm going to get something a lot lower than the real answer. So I'll do 1500 times 20. So 2 times 15, which is 30, and then count my zeros. I've got 1, 2, 3 zeros. Okay, so remember I rounded down a lot here, so my answer should be above 30,000. So I would choose 36,133 as my answer without having to actually do those calculations. Then we'll look at the second option where we're multiplying by this number, which is almost 1. So I'm expecting the answer to be almost the same as 1111. Okay, but remember I'm a little bit below 1 here, so looking at my options here that are close to the original answer, I'm expecting something a little bit lower than 1. So I'll be choosing C and moving on without trying to do any actual multiplication at all. You can also apply these same rounding strategies to division or percentage problems. So for this problem, 1,789 divided by 50. Okay, remember we don't have time to do long division. So I'm going to just say this is approximately 2,000 divided by 50, okay, which is the same as me trying to find 200 divided by 5. Okay, so I know that would be about 40. And now let's have a think about the rounding that we've done. To get 40, I shared $2,000 between 50 people. I don't have $2,000, I've got a little bit less than that. So each person is going to get a little bit less than $40. Finally, in a percentage problem, 46% of 6,099, I can do some rounding. 50% of pretty much 6,000. So I did a fair bit of rounding in that percentage there. Okay, 50% of that amount would give me 3,000. Half of that amount, I want a significantly lower percentage than that. So I'll choose the amount that's lower than 3,000. So have a go using these rounding techniques in the quiz that follows. In some problems, you may be able to use a really quick mental method. That's great if you can. If you can't, then go ahead, round, find an estimate, and move on to the next question.